So now we've learned logarithms and some of the rules with logs, we can actually solve much more difficult questions using these. An example of this would be, say, 2 to the x is 4. Now this is simple, right? Because we know, well, 2 squared is 4, so x is going to have to be equal to 2. But if I now change this slightly to, say, 2 to the x is 5, in this case, we know there's no integer value which will satisfy this equation. So what we can do instead is, as we did before, change it into a log form by saying it's equal to x, let's say x is equal to log 5 to the base 2, plug it into our calculator and we'll get 2.323. So that's simple. But now let's say what happens if I say 4 to the power of 2x plus 1 is equal to 20. Well, once again, this should be fairly simple because I can rearrange it to, well, in log form again, so I'll have log 20 to the base 4 is 2x plus 1, rearrange for x, so x is going to be minus 1 plus log 20 to the base 4 over 2, giving me 0.58. So until now is everything we've done so far. But from here, we can actually now look at another example where we have 3 to the x is equal to 2 to the x plus 1. So we have exponentials on either side of the equal sign. In this case, we can't really change it into the log form we did before. And instead, what we're going to do is we're going to say we're going to take logs to both sides. You know, in maths, we can like multiply the same value to both sides or minus the same value to both sides. What we're going to do now is taking logs to both sides. What that essentially means is that we're going to write it as log 3 to the x is equal to log 2 to the x plus 1. We took logs to both sides. If they don't really have a base, what that essentially means is that it's just the standard base would be 10. So in the case there's no base, just imagine that's a base of 10, but you don't have to write it in. And this can be seen on the calculator. So you remember, if I go to shift on the calculator and press the dash line, you will see a log function pop up, but there won't be an option to put a base in. This one is the one you should be using when we're not given a base number. Anyway, back to the question. So we've taken logs on both sides. Now what we can do is apply the log rules we've learned. So we've got x's which have been raised to power. So using the power rule, we can bring them down to get x log 3 is equal to x plus 1 log 2. Now it's just a matter of manipulating it, moving to one side. So expanding the bracket, we'll have x log 3 is equal to x log 2 plus log 2. So I'm going to bring the x log to this side. So that's going to give me x log 3 minus x log 2 is log 2. I can factorize the left-hand side and divide to leave x, right? So that will give me x is log 2 over log 3 minus log 2. And if I plug that into a calculator, I'll get a value of 1.71. Let's try another example like that. So let's try this one here. Once again, we have two exponentials on both sides. So in this case, what we do is take logs on both sides. So we're going to have log 4 to the power of x plus 2 is equal to log 5 to the power of x plus 1. Now we use the rules to manipulate it and make x the subject. So using the power rule first, we'll bring the x plus 2 down and the x plus 1 down. We now multiply out the brackets to get x log 4 plus 2 log 4 is equal to x log 5 plus log 5. Let's bring the x's to one side and the other to the other side. And then we can factorize and divide, leaving us with x is equal to log 5 minus 2 log 4 over log 4 minus log 5. If we put in the calculator, we'll get a value of 5.21. Right, and the final case where we use logs is in this kind of question here. So you can see here, this is technically, or it looks like a quadratic equation. So the way I'm going to manipulate it is say, let's let capital A equal to 2 to the x. In which case, I can now change this equation in terms of a to give me a squared plus 3a minus 4. I can factorize to get a plus 4, a minus 1, giving me a is 4 and a is 1. We found the values of a, but remember a was 2 to the x, right? So I can say 2 to the x is negative 4 and 2 to the x is 1. Writing that in log form will give me x is equal to log minus 4 to the base 2, or x is log 1 to the base 2, which means this first one will give me no solution and the second one will give me a solution of 0. So these are the three different types of cases where we have to use logs. Make sure you practice some of the questions I've listed out later on and make sure you're comfortable with dealing or using and manipulating logs.